Hi everyone, welcome to Cloud Computing series. In today's video, we'll be learning about virtual machines and virtualization middleware. So this is the architecture of virtual machine configurations. Yes, the first one is a physical machine. What it is showing a regular computer setup, right? See, the layers are hardware layer, then operating system, then application layer. It's a normal computer with a one operating system running directly on the hardware and apps running on the operating system. Then second one is a native virtual machine. What it is showing a virtual machine setup where the virtual machine monitor runs directly on the hardware. The layers are hardware, virtual machine monitor, then guest operating system, then guest apps. Yes, the virtual machine monitor, also called as a hypervisor, sits directly on the hardware and creates a virtual machines, each with its own guest operating system and apps. Then third one is hosted virtual machine. It is showing a virtual machine setup where the virtual machine monitor runs on the top of the host operating system. Yes, then the layers are hardware layer, host operating system, then virtual machine monitor, then guest applications. The host operating system runs on the hardware and a virtual machine monitor runs as an app on the host operating system, and creating a virtual machines with their own guest operating systems and apps. Then fourth one is dual mode virtual machine. See, in this architecture, the layers are hardware layer, then host operating system, then virtual machines split into privileged mode and non-privileged mode, then guest operating system, then guest applications. See, the virtual machine monitor works into two ways. One part has direct control of the hardware, that is privileged mode, and another part runs on the host operating system, that is non-privileged mode. So a conventional computer has a single operating system image, that is a normal computer runs only on a one operating system at a time. Then next is, see, this offers a rigid architecture that tightly couples application software to a specific hardware platform. That is, software is built to work with a specific hardware and operating system. If you switch to a different system, the software might not work. Yes. See, many computers waste resources because they can't easily share the power, and applications are hard to move across different machines. Yes. Then managing a software updates and security is complicated. Yes, and next is, see, a programmer that works on a one computer may not work on another with a different type of processor or operating system. Yes, next is, see, virtual machines offer a novel solutions to underutilized resources. That is, virtual machines allow multiple operating systems to run on a one machine. Then application inflexibility means they solve problems like wasted resources and software incompatibility. Then software manageability and security concerns in existing physical machines. That is, they make a software easier to manage and more secure. Yes, see, today to build large clusters, grids and clouds, we need to access large amounts of computing, storage and networking resources in a virtualized manner. That is, big systems like cloud computing and data centers need to manage massive amounts of computing power, storage and network connections. Then virtualization helps combine these resources and present them as a single system. That is the power of virtualization. See, we need to aggregate these resources and hopefully offer a single system image. Again, virtualization combines multiple computers into one system, making it easier to manage. Yes, see, cloud computing needs to share and manage processors, memory and input-output devices efficiently using virtualization. Thanks for watching. If you found this video helpful, don't forget to like, share and subscribe for more insights on cloud computing. Also check out our playlist for more in-depth topics. See you in the next video.